chapter 12 has a lot to do with right triangles and trigonometry, which you did in geometry. Okay.
I did not this.
You'll be fine. We'll take it slow, and you'll remember everything, and it'll be great. So, okay, so trigonometry is the study of relationships among the angles and sides of a right triangle. Okay, so you can use trig to find sides and angles in right triangles. A trigonometric ratio compares the side lengths of a right triangle. A trig function has a rule given by a trig ratio. So we use the Greek letter theta. Okay, so if you see this symbol, it is a theta. Often used to represent the measure of an acute angle in a right triangle. Okay, so those other two angles in a right triangle are acute. Okay, so you have one 90-degree angle and you have two acute angles. So you have the hypotenuse, the leg opposite theta, and the leg adjacent to theta. Okay, adjacent means next to. Okay, so if you forgot what adjacent means, it means next to. Okay, so these are used to define the 6 trig functions. So on the triangle below there, we want to label the sides of the right triangle with respect to theta. So theta is right here. That's your acute angle. The hypotenuse of this triangle would be opposite the 90-degree angle. Okay, so this is the hypotenuse. Okay, so that side of your right triangle is called the hypotenuse. The side opposite theta, okay, so that would be across from, is the opposite side. Okay, then your side adjacent is the side next to theta. Okay, that would be side CB here. Now, if you notice, there are two sides next to theta. One of them is always going to be more specifically the hypotenuse. So the other side is your adjacent side. Okay? So we have our 6 trig functions here. Okay, the first one is sine. Okay, sine is opposite over hypotenuse. So you would take sine of your angle theta, and it's equal to the opposite side length over the hypotenuse length. Okay, our next one is cosine. Okay, so cosine is the side adjacent to theta over the hypotenuse compared to theta. Okay, then we have tangent. Okay, that is the opposite side to theta over the adjacent side next to theta. Now the 3 that you probably haven't seen before are cosecant, secant, and cotangent. So cosecant, or CSC, that one there, is hypotenuse over opposite. So it's the inverse of, well, not inverse, it's the opposite of sine. Okay, so sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So you see those fractions, how they just take the reciprocal. Okay, so cosecant is the reciprocal of sine. Okay, same thing with secant. Okay, secant is the reciprocal of cosine. So now it would be hypotenuse over adjacent. Okay, and then cotangent is the reciprocal of tangent. So now you would have adjacent over opposite. So once you find these three, it's easy to find these ones because you just take that reciprocal. Okay? So examples here from this triangle. So sine of theta, sine again is opposite over hypotenuse. That would be the opposite side of 4 over the hypotenuse of 5. So 4 over 5. Okay, if I wanted to find cosecant then, since sine is 4 over 5, cosine or cosecant would be 5 over 4. Okay, so again, it's just that reciprocal. Same thing with cosine. Cosine is adjacent, so the side next to, which is 3, over the hypotenuse is 5. Okay, then secant would be that reciprocal of that fraction. Then tangent is opposite over adjacent, so 4 over 3. So cotangent is the reciprocal of 3 over 4. Okay? How to remember sine, cosine, and tangent? Okay, we remember SOHCAHTOA. Okay, SOHCAHTOA helps you remember what your ratios are. So the SO part would be sine, is opposite over hypotenuse. C or CA is cosine, adjacent over hypotenuse. And TOA is tangent, which is opposite over adjacent. Okay, so in our example 1 here, we want to find the 6 trig functions for angle G. Okay, so we're going to treat angle G like theta. Okay. So from angle G, I'm going to label each of my sides. So the side opposite the 90-degree angle is always your hypotenuse. Okay, so that side would be your hypotenuse. The side across from theta or angle G, so all the way across, is your opposite side. And the side that is next to is your adjacent side. Okay, so just labeling out those sides given that angle theta. Okay, so now I can find each of my trig functions from angle G. So the first one would be sine of angle G. Okay, so sine is opposite over hypotenuse. So we need our opposite side is 24. Over our hypotenuse is 40. Now we can reduce this fraction. Okay, both of them divide by 8. Okay, so 24 divided by 8 is 3. 40 divided by 8 is 5. Okay, so that's sine of G. Next, we're going to do cosine. Okay, cosine is adjacent over hypotenuse. So from our angle, we need the adjacent side is 32. Over the hypotenuse is 40. And again, reduce your fraction. Again, both divide by 8. So I end up with 4 over 5. Okay, then we have tangent of G. Tangent is opposite over adjacent. So our opposite side is 24. Over our adjacent side is 32. And that is 3/4. Okay, now you have to do the other 3. So, yeah, 6. 6 trig functions. So we need cosecant of G. Now again, cosecant is just the reciprocal of sine. So all you have to do is take the reciprocal of the fraction you already found. So this one will be 5/3. Okay, then we have secant, which is the reciprocal of cosine. So take the reciprocal of 4/5. That is 5/4. And then cotangent of G, take the reciprocal of tangent, So 4/3. Those would be your 6 trig functions. Okay, questions on how I did example 1? I just used those ratios from above for each of my trig functions there. All right, then number 2 is a little bit different. In number 2, you're given what tangent of angle A is. Okay, it is 5/3. So we still want to find the exact values of the 5 remaining trig functions. So what I would do here is draw out a right triangle. Okay. Now if you're using a trig function, you can't go from that 90-degree angle. So it always has to be one of the acute angles that you're going from, meaning A has to be either this angle or this angle. It can never be the 90-degree angle. Okay, so I'm just going to label this one as A. So now I know tangent is opposite over adjacent. So the opposite side from angle A is this side. Okay, meaning that side has to be 5, since this is the opposite and this is the adjacent. Shh. Then I have the adjacent side to angle A. That's the side next to, that's not the hypotenuse. That side has to be 3. Shh. Stop talking, please. Shh. Stop it. Okay, the remaining side is the hypotenuse, right? So in order to find my remaining 5 trig functions, I need that hypotenuse. So since this is a right triangle, and I know 2 of the sides, I can use the Pythagorean theorem to solve for that final side, which is a squared plus b squared equals c squared. Okay, that's the Pythagorean theorem. C squared is your hypotenuse. Okay, A and B are your 2 legs of your right triangle. So I can plug in 3 for A and 5 for B, because I'm trying to solve for that hypotenuse. So I have 9 plus 25. That's 34. Okay, now when I have c squared is equal to a number, you need to take the square root of both sides. Okay, so c will be equal to the square root of 34. Okay, and you're going to leave it like that because it's looking for the exact values. So now I can go through and find sine, cosine, cosecant, secant, and cotangent, since I'm already given tangent. Okay, so we have sine of angle A. Okay, from angle A, sine is opposite over hypotenuse. Okay, so my opposite side is 5, and my hypotenuse is the square root of 34. So I would have 5 over the square root of 34. Now I can't leave that like that. No, I can't. Okay, you can't have a radical in your denominator. So since that radical is in the denominator, what I can do is multiply by the denominator on the top and bottom of my fraction. Okay? So when I do that, I end up getting 5 times the square root of 34 over 34. Because I have 2 sets of 34s, that cancels out your square root. Okay, so that would be sine of angle A. You want to make sure there's not a radical in your denominator. Okay, next we have cosine of A. Cosine is adjacent over hypotenuse. Your adjacent value is 3. So we have 3 over the square root of 34. Again, I can't have that in the denominator, so I need to multiply by a version of 1, which is the number from the denominator over itself. Okay, that will be equal to 3 times the square root of 34 over 34. Okay, we already have tangent, so we don't need to find that one. So I'm going to move on to cosecant of A, which is the reciprocal of sine. So I'm going to go back to what I originally had for sine and just flip that fraction. So now this will be square root of 34 over 5. Okay? What? Nope. You only have to multiply by a version of 1 if the square root is in the denominator. Okay, then I'm going to go to secant of A. So again, look at your original one you wrote down. Take that reciprocal. So we have square root of 34 over 3. And then cotangent of A. Look at tangent of A, which was in the directions. That was 5 over 3. Take the reciprocal of that fraction. That's 3 over 5. So those are your 5 remaining trig functions for A. Okay, so if you get problems like that, you need to draw out the triangle, label it with that angle value. That angle should be one of the acute angles in the triangle that you drew, not the 90-degree angle. Okay? Questions on that? All right, then we have some special right triangles. Okay, so those are 30, 60, 90 right triangles and 45, 45, 90 right triangles. Okay, so those are your 2 special right triangles. With 30, 60, 90 right triangles, I do have these up here for geometry. These are the rules for them. If you have sine of 30 degrees, so from this 30-degree angle, again, that's opposite over hypotenuse, it's 1/2. Okay? Cosine of 30 is square root of 3 over 2. Tangent of 30 is square root of 3 over 3. Sine of 60 is square root of 3 over 2. Cosine of 60 is 1/2. Tangent of 60 is square root of 3. 45, 45, 90. Sine of 45, square root of 2 over 2. Cosine of 45, square root of 2 over 2. And tangent of 45 is 1. Okay, so we're going to use those to help find missing sides in our right triangle. So in numbers 3, 4, and 5, we're going to use a trig function to find the value of x, and we're going to round to the nearest tenth if necessary. So we have to decide which trig function to use in these problems. So you're going to look at the angle that you're given, which is 60 degrees, and you're going to go from that angle and see what sides you have compared to that angle. So what would this side of 14 be? What would you label that side as? Hypotenuse. Right? And then the side that has the x would be which side? It's adjacent. So your opposite side has to be across from that angle. Okay? That's your opposite side. So looking at my values, my 2 lengths that I have, I don't have x, but I have a label on that side. Okay? I would use adjacent and hypotenuse. Which one of my 3 main trig functions uses adjacent and hypotenuse?
Cosine.
Cosine. So I'm going to use cosine of 60. Okay, that's equal to that ratio of sides, your adjacent side, which is x, over the hypotenuse is 14. Now I'm going to get x by itself. So I'm going to multiply both sides by 14. That way they cancel out here. And I have 14 times the cosine of 60 equals x. Well, if I look at my chart up here, what is cosine of 60? What's cosine of 60? 1/2. So I can replace this cosine of 60 with 1/2. So I have 14 times 1/2 equals x. Stop it. So x would have to equal 7. Now you can use these, that's fine. If you know you're finding the adjacent side, that's the short side of this one. Okay, so you just take 14 divided by 2 to get the short side. We're going to do it this way.
Wait, where did you get the 1/2 from?
Cosine of 60 is equal to 1/2. So I just replaced cosine of 60 with 1/2. All right, we're going to do another one, number 4. So again, going from the angle you're given, that's 60. I need to identify the sides that I have in this problem. Okay, this side of 12 would be what? Hypotenuse. This side of x would be what? Opposite. Good. Okay, it's across from that angle. So you have an opposite side and a hypotenuse. Which one of your 3 main trig functions would that correspond to?
Sine.
Sine. So we have sine of 60. Okay, so sine of 60, since I'm going from that angle, that's equal to your ratio of sides, so the opposite over the hypotenuse. So that would be x over 12. Now again, I want x by itself. So I'm going to multiply both sides by 12. Cancel on the right. So we have 12 times the sine of 60 equals x. Now in my chart above, it tells me what sine of 60 is. What is sine of 60 in the chart above for that 30, 60, 90 right triangle? Square root of 3 over 2. So I can replace sine of 60 with square root of 3 over 2. Okay, if I have 12 and then this 2 here, what happens to that 12? You can divide it by 2, right? So I end up with 6 square roots of 3. Okay, so you could leave it like that if you want. If you plug it into your calculator, you get 10.4. So you can keep it as a radical if you'd like, or you can plug it in to get 10.4. Yes. There's multiple ways you can do these problems. However you need to.
10.4.
All right, then number 5, looking at the angle you're given, that's 45 degrees. Identify your sides. What side is x? Hypotenuse. What side is 10? Opposite. So I have O over H. That is sine. Okay, so I have sine of 45 is equal to the opposite side of 10 over the hypotenuse is x. Now for this one, you're not going to multiply by 10. What are you going to multiply by? X. You're multiplying by whatever in the denominator, so you don't have that denominator anymore. Okay, so they would cancel out on the right. So you have x times the sine of 45 is equal to 10. Now how do I get x by itself? divide by sine of 45.
Dang, smart.
Okay, so they cancel on the left then. So you have x equals 10 over the sine of 45. Now what is the sine of 45?
Square root of 2 over 2.
All right, when you have something
14.1.
like this,
Leave it. Don't touch it.
no, multiply by the reciprocal. That way it cancels out each term here. So you have 20 over the square root of 2. Now, since I said you can put it in decimal form, if you'd rather just take 20 divided by the square root of 2, you can, and get a decimal. If you wanted to simplify this radical, you would have to multiply by square root of 2 over square root of 2.
Yes.
To get 20 square roots of 2 over 2. Then I have 20 divided by 2, which is 10. And square roots of 2. So in exact form, this problem would be 10 times the square root of 2. If you plug it into your calculator, you do get 14.1. And you do have a sine, cosine, and tangent button on your calculator. So you could do it that way as well. And I think that's the way Ethan did it.
Mm-hmm.
Oh, okay. Any questions on your special right triangles or